Hey, hi everyone. Let's solve today's daily challenge, that is maximum level sum of a binary tree. Right. So let's see what the question is. So in this question, we're given the root of a binary tree. The level of its root is 1, the level of its children is 2, and so on. And we need to return the smallest level x such that the sum of all the values of nodes at level x is maximal. All right. So let's see what the question is. So basically, it's nothing. It's just we are being given a binary tree, right? And we are just talking about level wise. So root level, let's say it's 1, right? And then this level they are saying it's 2, and so on, right? So this is the way that they're defining the levels within this binary tree. Now, what we need to do is we need to return the smallest level x such that the sum of all the values of nodes at level x is maximal. So basically, out of all of these levels, we want to return the smallest level x where the sum of that level is going to be the maximum. Okay, so basically, as you can see, what we are talking about in within this problem is using levels, right? So all we are concerned about is the level of the binary tree, right? So this is the first level, this is the second level, this is the third level. So one thing is very clear from here. We don't need to go ahead and discuss other things before we have realized that this is a problem for that involves using level ordered reversal, right? So we would be using BFS in this. Okay. All right. Now since we know that, what is the next thing? That is, we need to return the smallest level x. So basically, we want to know the sum of each and every level, and at whichever level we get the maximum sum. So it could be two levels also having the same sum. So in that case, we have to return that smallest level x, right? So that is what the question is. And we have also figured that we have to solve it using what? Level ordered reversal, right? So it's an easy question, I would say. It's not there's not much logic involved or any tricky things as such. Simple level ordered reversal, and it's just you need to modify this BFS a little bit in order to calculate the maximum sum, right? As well as you have to also keep track of the level that you are on, right? So you will have to have two values for that. Let's say one value to know what the current level is, and the next value to know what the level that you will be returning as the answer. That is where your max sum is being achieved, that level value. So let's just call it result level, right? So these are three of the things that yeah, along with maximum, you also have to obviously calculate the sum. So these are four things that you need to um, use to modify the usual BFS that we do, and we would be good to solve this problem, right? So now let us see how we would do that. So basically, let's first see how we do a BFS traversal, right? So in BFS traversal, what we do is we maintain a queue, right? All right. So what we do is we feed the root node to that queue, and after that we loop until the queue is empty. And then what values do we input in the queue? So let's just for this example, let's create a queue, right? So right now the queue is empty and it contains one, the root value. So we push this root value. Now we start looping within this queue. So what we do is, for each and every value that is within the queue, we push within the queue the children of all of these values, right? So for what we see that there's only one node right here. Okay, so what we do is we push left and right child of this node into the queue, and we pop this. All right. Okay, so in the next step, what will happen? This value will be popped, right? And 7 and 0 will be inserted within the queue, right? Now, after this, we loop again, right? We check what are all the values within the queue, and then we keep popping the very first value that we found, and also keep inserting the children of that particular node, right? We pop this value, all right, and what do you insert? So here it will be 0, right? And what do you insert? 7 and -8. And also, before we start traversing in the queue, whatever is the original state before we start looping, right? that state you need to know. So we can calculate simply the size of the queue before we loop. So n is equal to 2 in this case, so we'll only loop 2 times so that we ensure that we do not touch the children of these nodes, right? Okay, so after this, if you see, our queue will become, for 0 there is no children, right? So now the queue contains this, and 0 we have popped out. So if you see, this is the level 1, right? And after this we created the level 2, and after this iteration we created the level 3, right? Now what we will do is simply maintain the sum value also. So while we are iterating for this and pushing the children of these particular nodes within the queue, we will also keep calculating this sum, as well as we will maintain this current level. So initially what we'll say, our current level should be equal to 1, result level obviously it will be equal to current level, and max value of course it will be 0, or you can use this one, but since we'll be looping, it will still be calculated, so you can start with the max or some value as 0 and some value as 0, right? So this is how you start. Now you come to level 1, and you basically take this node out and calculate that within sum right here. And then after you have completed all of this iteration for a particular level, you simply have one check, that if sum is greater than the max sum that we might have calculated earlier on, in that case you update your result level to the current level. So result level becomes equal to the current level, right? Since we got a sum value that is greater than the max sum that we are keeping track of. And then also update this sum value to maximum for the further levels. Okay, so yeah, so this is how you have to basically solve this question. Let us quickly look at the code for this. All right, so here if you see, oh yeah, one more thing, you will have to take maxsum as int min. Reason being, the values can be negative as well, right? So that is why we're taking maximum as int min here. All right, then if you see, result level is 0, current level is 1, and then we have initialized our queue. So initially we push the root node within the queue, then we are looping within the queue until the queue is empty, right? And as I had mentioned, that we will have to keep track of what initial number of nodes are within the queue, so that we make sure that we do not touch the children of the nodes that we are about to push into the queue, correct? Then we are also keeping track of the sum value. All right, then while n minus minus, so basically for the given number of nodes that were present within the queue, we are looping here. All right, then we are pushing what, the children of the nodes that are already present within the queue. So if you see, we are first taking the front node out, also popping it at the very same time, also calculating the sum value by using this node, and then we are pushing the children, left and right children within the queue, right? Then after we have done this for all the nodes, by this iteration we would have calculated the sum of that particular level, right? Now we are checking here, if this sum value is greater than the maximum value, right? Then we will update the maximum to the sum and result level to the current level, and also we will keep moving the current level by 1 for each of these levels, right? And in the end we are simply returning the result level, right? And also if you see, we are not having this equality sign, so we make sure that we are not returning just any level with a max sum. We are only returning, we are only going to return the smallest level x, for which the sum was maximum for the all the levels in within the binary tree, right? So yeah, so that would be it for this question. I hope I was able to help you solve this. Thank you.